Our second speaker this afternoon is going to be Lee Howard. He's the Director of Network Technology at Time Warner Cable. He'll be talking about some interesting work they're looking at costs of IPv4 and IPv6 dual stack.
Good afternoon. It's always fun to talk in the middle of the afternoon because everybody's had lunch, it's bright and sunny outside, so everybody's had a chance to gather some rays, and now we're inside and it's a little dim. So I'm going to try and stay lively. I may not be able to be quite as lively as the last time I was here. Back at NANOG in Dallas, I talked about the total cost of ownership of carrier-grade NAT. And my conclusion was it's kind of expensive. And I then compared the cost of carrier-grade NAT to the cost of buying addresses, IPv4 addresses, on a transfer market. And I kind of came up with some comparisons and some ramifications there and had a lot of fun with the thought experiment. And one of the questions that every time I talked about it, one of the questions that kept coming back was, well, okay, the alternative, you keep saying everybody needs to go add IPv6, everybody is going to run IPv6 anyway, but what does it cost to do IPv6? And I kept saying, well, it's too hard, there are too many different things, there are too many variables, it's too far different from company to company to figure it out. And finally I said, all right, it's time for me to sit down and say, is there at least a framework by which we can sort of evaluate what the possible costs are? And are there any kinds of ways that we can cluster similar things together? And so that's what I wanted to come and talk about today, is to try and provide a framework to help people think about what costs are for a given, whether it's company, organization, network, segment, or the internet as a whole. So the structure that I've created is to say there's the deployment cost, what it costs to enable IPv6 dual stack to begin with, and then there's the ongoing operational cost, what it costs to maintain a network that is running dual stack. And we're going to talk about dual stacks as opposed to single stack because I've already talked about what if you're doing a carrier-grade NAT solution or a buying addresses solution. So this is sort of the other side of that path. And the way it looks to me is that it's reasonable to sort of break things down into these various segments. So data centers, hosting providers, content providers tend to have similar sets of things to look at when it comes to what their costs are going to be. ISPs tend to have similar things. Enterprise networks tend to have a certain set of things. And obviously there are similarities between them, and I'll talk about those when I get there. But that's the fundamental part that I wanted to get to was deployment cost and operational cost. It's very important for me to acknowledge the people who helped me with this. So the way I went about trying to figure out what the framework would look like is I said, gee, there are, in fact, documents describing how one should or could dual stack one's network, whether one is a data center operator or an ISP or an enterprise network. So I went to the authors of those documents and said, I see the framework that you've described, I see the tasks that you've listed as needing to be done. What does it take to, do I have the costs right? Because those documents wouldn't necessarily describe the costs. So these people definitely gave me comments back, and I've incorporated their comments as best as I can into what I'm doing. Anything that's true and good, it comes from them. Anything that's bad, blame goes to me. So thanks, blame. Thanks to them, blame to me. In particular, I want to point out Richard Jimerson and the Deploy 360 team. I did get some comments from Jan George, who is around here someplace, and from Dan York. I'm not sure I got all their comments into the slides, so I'll try and catch those as I go. And Jan, feel free to jump up and tell me what I missed. So deployment cost, starting with data center. And this is, again, sort of lumping together similar-ish things from where I stand on the internet. The data center, hosting, content providers. Excuse me. Starting point here is draft Lopez v6 ops DC IPv6, which I've got listed on the slide. And so that's an internet draft that's being discussed at the v6 ops working group at IETF. And the idea is to say, if you're an operator, data center operator, what are the things that you need to think about as you're migrating to, as you're adding IPv6, as you're migrating to dual stack? So here's what it comes down to. You've got to do firewalls and routers and switches and security appliances and load balancers, all of the hardware that you have in a data center. It turns out, or it looks to me, like routers, load balancers, switches, most of these things actually support IPv6 now, and generally pretty well. Most of them support IPv6 pretty well. In general, existing hardware can support v6 in hardware. Some of them need software upgrades, new iOS versions or OS versions, new bug fixes, a few features, depending on exactly what you've implemented, sure. But generally, you don't need to buy new hardware. You just need to beat on your vendor to give you the features that you need. The exception here is security appliances. There's still a lot of firewalls, maybe yes or no, depending on how old your firewalls are. If you're running a data center and you have a really old firewall, it's time to upgrade anyway, okay? But other security appliances, your IDS, IPS, your washing machines, your scrubbers, your plugins for the guys with black hats, those things are blue hats, whatever hats they wear. Those things, yeah, they probably need to be upgraded. They haven't been coming along quite as fast as we probably all would have liked. So there may be some capital that has to be spent there. Servers, though, and that's really the bread and butter of the data center organization, the servers are done. Operating system, there's no hardware. And operating systems has been supporting, server operating systems support v6 forever. And that's true whether it's front-end servers or back-end servers. Now, the software running on those servers, that's a different question. And so there's, what's your data center doing? What's it there for? What are you? So your apps, the things that you're running in your data center, probably do need updating. And there, it's development dollars. So you probably need to have some people spending some time, whether it's your friendly neighborhood linear programmer, from the guys who were just giving a great talk, whether it's your website if it's custom, your mail or portals or all those things, they probably need development, and that includes the monitoring for all of those things. Now, I can't tell you whether those development dollars are capitalizable. That's a question for your accountant. I'm not an accountant. But there's probably some time required in there, so and that could be significant. So that's sort of mixed news, good news, bad news, right? There's some money probably required, but not that much. Let's take a look at the next set. ISPs, similar kinds of things. Now there's already an RFC out for strategies for dual stacking an ISP, wireline incremental IPv6. I'm one of the co-authors on that one, and it turns out, so there are a couple of different chunks of things that need to be done, but it turns out if your backbone isn't already IPv6 capable, you are running a really old or really small backbone. Like, you might want to consider using a vendor other than Belkin for IPv6 for your backbone. Your access network, though, depending on what kind of access network you're running, may need some upgrades. And again, it depends on how old it is, and whether it's your DSLAM, BRAS, your CMTS, whether it's your Livingston Port Masters, or whatever it is that you're using for your access network. Then you're probably you may have to do some edge upgrades there. But, again, probably about time, especially in Livingston Port Master, probably about time to upgrade anyway, right? Depends on where you are. The data center will go, you kind of refer back to the previous slides on data center costs. Provisioning systems. Now here, your provisioning and operational support systems, those are, again, same kind of development dollars, although the trick here for an ISP is that maybe depends on whether you wrote the systems in-house or bought off-the-shelf stuff. So it looks to me, though, as if you either need to write software, in which case you're going to spend a little bit more, or you need to at least do the systems integration to invoke the IPv6 calls within the software you got off the shelf. So there's going to be a little bit of work either way, and of course, work is dollars. Same with monitoring. It's a little bit more, there's a little bit more going on, I think, for ISPs because they have all of those different levels of things to monitor. And don't forget your customer ticketing system and your outage ticketing system, because you probably want to be able to reference the address or where the trouble is coming from in both of those. And then the big one is CPE. So the reason that's the big one is that that's the one that's a per customer cost. Everything else is you have to do this, and once you've done it, it affects all of your customers. CPE is per customer. Now, that could be whether it's modems or ONTs or acoustic couplers or fiber technologies, whatever it is, or it could be home routers. Whatever it is that your ISP puts in the home, that's what we're talking about. It needs to support IPv6. The good news is that many do. The bad news is that not all do, and there's a wide diversity of support among CPE provided by ISPs. It's incredibly wide, and we're seeing lots of great support from some ISPs and some CPE manufacturers, and a little bit less strong in other cases. So that's a big one. Now, I guess I meant to point out, those capital expenditures on CPE and your access network, capital expenditures in general are, well, they're cheaper if you spread them out over time, because you're going to do an upgrade anyway eventually, right? That's just, we accept that as being part of the normal life of a network. So you're going to do that upgrade. So if you just roll IPv6 support into that upgrade, you're fine. The trouble is that you may not have already started that upgrade cycle. So if you started 4 years ago, you're probably in pretty good shape right now. If you haven't started 4 years ago, then step one is get a TARDIS, because you've got work to do. And like IPv6, it's bigger on the inside. If you can't start 4 years ago, then you're probably going to spend really the same amount of money to replace equipment. It's just going to be in a compressed time frame. This is true for the capital expenses for any of these segments of the industry. The enterprise network. This is one I actually kind of like in this particular conversation, because there's nothing here where I've written in big green letters money. There's not a lot of capital involved to upgrade the enterprise network. So we've got another draft. I'm a co-author on this draft too, on how an enterprise network can include IPv6 support. And there are a couple of different strategies, and I don't want to debate because there are good arguments for working outside in or inside out, and there are considerations with either approach. That's not really the point. The point is that either way you start, you're going to have to deal with the same considerations. So on the external side, your access provider needs to support IPv6. I think that most major ISPs in the US and probably North America support IPv6 on their dedicated commercial access networks. I can't say that about residential access networks that might be sold to business or small home or SMBs. But when you go to buy fiber from an ISP, I think that all of the major ones will give you IPv6 support if you ask for it. Whether your particular sales engineer has heard of it is, potentially debatable, but I think they're all capable of it. You also have to worry about your WAN access. Now here I'm talking about the wide area network between your individual sites, assuming it's not through the internet. So if you're using one of the large ISP's private backbones to move traffic between your enterprise locations, that's going to need to support IPv6 too. Either, at least your part of it is. Your data center, go back to what we talked about before, probably writ smaller because there's a little bit less going on there, and enterprises are much more likely to have commercial off-the-shelf monitoring and data center software than either ISPs or certainly data center hosting content providers. Anti-spam, and I ought to include with anti-spam all sort of security things. Definitely you need to worry about that, and so that's one of the things that keeps coming up every time we talk about what's the first thing an enterprise needs to do with regards to IPv6. Well, the first thing they need to do is make sure their firewall doesn't forward IPv6 packets by default. You need to make sure that your firewall is aware of what IPv6 is and blocks it if you don't want it, or at least pays attention to what it is. And there are other considerations in there, and then go search for the best practices in security. Your anti-spam vendor may or may not have a solution, and you probably need to start talking to them. Monitoring back to your commercial off-the-shelf systems, make sure your vendors are supporting it. We're at the point now where it's pretty close. If your monitoring system vendor does not support IPv6, you have alternatives, and you can tell them you're not going to buy their system. It's okay, I give you permission. You can do that. On the internal side, obviously your local area network segments, again, we're talking about routers and switches. They support v6. I mean, if they're less than 100 years old, they support v6. If you've got vacuum tubes in your routers, then you've got a problem. Otherwise, run it. Workstations have supported v6 for years. The only workstation operating system that doesn't support v6 is Windows XP. Windows XP is end of support in April of 2014. Certainly, if you are subject to Sarbanes-Oxley rules, you will not be using Windows XP a year from now because you'll fail your Sarbox audit, because you can't get a support contract for it because Microsoft has declared it to be end of support. You can't get security patches for it. If you're not already in progress updating, replacing your Windows XP systems, you've got some work to do. And by the way, while you're building the new image for your standard workstation build, why not build v6 support right in there? You've got your engineers working on it anyway, do it. Peripherals are a little bit trickier because there are some that are sort of standard that we're all kind of used to seeing. I know that the The multifunction printer, copier, scanner devices in our office do actually support v6 mostly. We've noticed that they get a v6 address on the LAN, but then the address changes and the server doesn't know about the v6 address. So we're still sort of working out how we can use v6 for it. But that's the standard large printer, fax, copier, copier, scanner. It doesn't include the other kind of strange peripherals that you end up finding in the dark corners of an enterprise network, like the security cameras or the badge scanners or the little appliances that the folks in your network are building, the Wi-Fi, the rogue Wi-Fi access points that your employees plug in. All those things may not do IPv6 yet, but they might. It actually turns out that a lot of those things are being bought by companies that have been asking for v6 for a while. So you may not have to do any replacement there. Server room, same kind of stuff. There's a trick here that I'm not, your accounting system, your HR system, your payroll system, all those internal corporate systems may not support IPv6, or they might be running on just using the library that comes with the operating system, and they do. You're gonna have to do some testing, but you're probably okay, and you're not gonna, I wouldn't expect you to have to spend any more money to get there. All right. That's what it costs to get to running dual stack. So there's some money in some of those cases. In the case of the enterprise network, it's mostly labor. And I'm sorry, because I know that's the hard thing for enterprise network operators. It's labor. There's a lot of work to do, and you folks, you have a lot of work to do already. But at least there's no capital. You don't have to go defend a major expense. Operational costs. Now I think it starts to get interesting. So what happens once you're running a dual stack network and you have a router code version upgrade, or even you're evaluating a new router for your network? How many times do you have to test that? Probably at least twice, maybe 3 times. And here are the iterations, and they're here. So you're going to do the same testing you've always done, right? Because you've always done it, and you have to do that, at least that much testing. And whether that's just a unit test for the new features or it's a full regression test, I don't know. It's your network. You test it how you want to. But you're at least going to do the same tests. Then you have to do the additional tests for the v6 specific stuff, making sure that it actually spells v6 correctly and does neighbor discovery and all the important things. Now, do you do an IPv4 iteration and a dual stack iteration and an IPv6 only iteration? Or do you just do v4 and dual stack? Kind of up to you. Your rules, your network, you decide. But there's going to be additional work. Any way you look at it, every time you evaluate a new vendor or new code, there's going to be additional work because you're going to have to test a couple of extra things. How much work? Well, okay, once you've got the hardest part in evaluating a new router is actually plugging the thing in, is getting the darn thing racked in your lab and getting it plugged into the right places and getting it configured and making sure all the connections are working. And then you can actually start running your tests. And once you have your test plan going, adding on an additional set of test plans doesn't actually take that much more work. It's not that much bigger, that big a deal. So that's how you may have to do 2 or 3 rounds, but it's probably only, if it takes you a day or 2 to set everything up and half a day to test, maybe it's only another hour or a couple to add on the v6 or the dual stack round. So it's probably only 10%. That's not that big a deal. Your QA group, if you have a separate network engineering and QA, may have to do the same thing. And there's the operating control, so there's some extra money there. There's a little extra time. It's going to cost a little bit more. Now, operating and troubleshooting. Okay, so we have just kind of problems at the ISP tend to fall into layer 1, layer 2, layer 3, generally not too much higher in the stack. Now, if it's a layer 1, layer 2 problem, generally, once your ping 6 works, your ping works, right? Yes, you probably do want to be thorough and also ping. You notice that I'm starting with ping 6, of course, because naturally that's the one you'll troubleshoot first, right? You want to build those good habits. But once, adding an extra ping, that's what, 30 seconds? Big deal. That's nothing. That's, trivial. A layer 3 problem may or may not be separate, depends what the problem is. If your BGP, if you've got different paths, if you're trying to troubleshoot why your IPv6 path is much longer than your v4 path, that's a totally different, you've got 2 different sets of things to look at. It's going to take you twice as long to troubleshoot that as when you were single stack. If you've got your BGP session is down, all right, once your session's back up, you're probably back up on both families. So again, do a ping 6, add in a ping, maybe a trace route, and you probably are good. So there's a little bit of extra cost there, but it's not huge. Data center, again, very much like adding a router or other major equipment to the ISP network, is those apps have to be tested twice or maybe 3 times. Here's the hard part. Depending on your app, and I got widely different answers from the experts in this field, depending on your app, either you're just using the standard libraries, you just updated your libraries, and from now on everything is a breeze and you're just being more thorough in your testing, or you have separate code trains and you're essentially building your app twice. Depends on how low level your application is. If you're building it twice, there's going to be a lot more work. Not the whole thing, but it could be as much as 30% additional work to run dual stack compared to single stack. Again, once you've got the plan in place, once you've got your tests automated, you've got your load generator, whatever it is, once the tests are underway, the additional testing is probably incremental. Testing, your QA folks, again, same thing. And again, there's the difference between your regression test and your unit test, but it's still probably moderately incremental. And I come up with pretty much the same things for troubleshooting. It's a data center network, so it's a different kind of set of problems, but generally, once the physical problem's fixed, once you've got connectivity at layer 2, layer 3 is ready to come up, and you do your ping 6, you do your ping, you're good to go. Enterprises, again, a little bit different because it's a different kind of environment. Systems, workstations, peripherals, kind of what I said before, probably 10% additional work, additional testing, like, okay, so you're testing the current version of Windows or Mac OS. In another year or 2, you're testing another version, you've got more work to do because you have to test both. But once the plan exists, repeating is incremental. And support, well, okay, so it looks to me that this additional support cost is really small because there are very few backhoes in the office building. So your physical fiber cuts or copper cuts are much smaller. Here's the summary. This is what I was working my way up to. The summary is, if you're a data center, hoster, or a content provider, there's going to be some money spent in your application's development. There's a little additional work. You're probably going to have to spend some CapEx on new security devices. And I don't know whether it's CapEx or labor for your monitoring systems. That depends on what you have. And it may be as much as 5 or 10% annually, potentially up to 30% annually to operate dual stack. Now I got to be clear here. I'm not actually saying it's 30% of your OpEx over your current OpEx. That would be a little bit much because there's an awful lot of things that go into your overall OpEx, not just development and monitoring and those systems. But for those things that I mentioned earlier, the costs are significant. I mean, not insurmountable, but there's additional cost there. Similarly for ISPs, access routers, CPE, those are the big things. Access routers may be okay. CPE depends on what you think your time horizon is for the transition. And then more labor, either integration or development for your provisioning and OSS systems. And similarly, more money to operate the network. For the enterprise network, hey, CapEx is cheap, that's good, but it's going to take you some extra hours. Maybe it's time to bring in some consultants or just have some folks, put folks on it and plan for a slow migration. And the operations differential is fairly small. Now here's what I really wanted to come to. Here's the point that I wanted to make, which is these are additional costs of dual stack over single stack. Now right now, pretty much everybody's single stack on IPv4. Probably a lot of networks are going to be running dual stack for some time, but you get this money back. You get to save this money when you can go single stack to IPv6. So how do you get to the point where you can single stack and realize some savings again in the future and not have to operate both of these protocols at the same time? So that's what I'd really like to have people thinking about. How do we get to that point? Because there's going to be some additional pain. It's going to be a little bit more work for all of us for some amount of time until we can actually get to that point. So that's what I wanted to say. Thank you very much. I'd love to entertain discussion. Okay.
Brandon Ross, Network Utility Force. So there's 2 parts of your presentation I wanted to comment on a little bit. And I'm speaking mostly from, we do a lot of work with small service providers, so kind of your mom and pops that run either a small DOCSIS system or maybe GPON or whatever else, but there's a lot of these guys, independent operators. So the access gear problem for these guys is a major cost problem, right? I agree with you that their backbones are generally upgradable. They're not usually running really ancient, Netgear routers in their backbones. Most of them, maybe the WISPs might be, but most of these established, telco co-op kind of guys, they're mostly running relatively recent gear in the backbones. But the edge networks are a very big cost problem for them. So to tie that into what you're saying we should think about, which I agree with, is what that looks like as you move to single stack. But I think there's for some of these guys, an extended period of time when it's not just dual stack, but dual stack with the transition technology to deal with the fact that their edge networks are not dual stack capable natively and probably won't be still for quite some time because their upgrade cycles are going to be, some of them fairly long because of the very small margins in that part of the market. So.
Yeah, I think that is a really good point, that especially in rural areas where you don't have a density of population, buying a new line card for a CMTS or new logic cards for your BRAS, that's a big deal for an ISP with 1,000 or 10,000 or 20,000 users. That's a big deal. 6RD has been proven to work by very large ISPs in the U.S., so that's a viable potential strategy, but you're still running dual stack.
Right, you're running dual stack plus the cost of the 6RD technology, which I think we'd all agree, for especially someone that size, is probably also significant.
Yes.
So I think it's an interesting comment, at least, to think about that in some of these styles of networks, it's even more expensive because they can't quite upgrade their edge. But
it would be interesting to think through what the long-term strategy is for the small ISPs to get to a single stack V6. I can think about what it might look like for a large ISP, but yeah, interesting further thought. Yeah. Yep. Yes.
Hey, Chris Griffiths, Comcast. Wondered, in the analysis that you did you put any time into training, in particular for OpEx costs associated with that?
Thank you. That's exactly the comment that I said Jan George had made a comment, and I needed to make sure that I included it in my slide, and I forgot to put it there. So training is potentially, possibly, might be a big deal. It depends on how many people you need to train and how dumb they are. So it also depends on how you want to do your training. So I think that probably for most of us, the folks in our network architecture engineering groups, they don't get training. They read manuals, they read the documentation, they talk to the sales engineers, maybe they read an RFC, and they break things and they fix it. Compared to a network operations staff or somebody whose job involves driving a cherry picker, those guys don't know a whole lot, and they need a lot more support because they're not quite as far along in their careers. So yeah, they do need a lot more support. How much do you get? How do you do that? I don't know, and I have not actually I have not thought of a way to model how significant your training cost is. There are also lots of publicly available free or free-ish learning and training facilities. Another shout out to Deploy 360 at the Internet Society. Obviously, Aaron has a wiki. All the RIRs have wikis. So there are resources, but how do you actually make that available and not just make the junior engineers go hunting for it? If you have thoughts about how to model that, I'd love to hear them.
I have a question. So my question was, have you given any thought to how these costs change over time, over a year, 2 years, 5 years? Do you see them increasing linearly, decreasing, exponential changes?
The ones that I talked about saying, gee, security appliances have only just started adding features, you might need new appliances there, those costs go away in a couple of years because they're built into whatever you're buying next year, the year after. The same is true with CPE because there's probably some amount of churn and those costs and those devices are getting replaced through some natural cycle anyway. So those costs are generally reduced, and the more time that goes by, the more stuff we can assume already has V6 built into it. The point about small ISPs and their access networks, there may be a longer cycle there, but yes, absolutely, the capital costs are decreased over time. The operational and software development costs probably don't reduce over time because that work is going to have to be done one way or another anyway, at some point. Do we have time for one more?
David Barak, AT&T. What life cycle time were you assuming for the non-Belkin backbone gear? Because the life cycle tends to be pretty long, and feature parity in V6 and V4 is less than ideal even in core gear.
So it depends entirely on which features you're using in your backbone. For many of the largest backbones, and I can't speak for yours, but I can speak for several that I've seen and heard from, they have been running IPv6 on their backbone for 10 years. So now you may have some very clever advanced features running in your backbone, and you're using specific features that drop out of the hardware path, and you have to do software forwarding if you do V6. Bummer. So I don't have a solid answer for that. My rule of thumb has been if anything's less than 4 or 5 years old, it probably does speak V6. Backbone stuff is even older because those guys figured it out earlier. Did I answer your question at all, or did I evade it completely?
So you're assuming about a 4-year cycle?
For most things, yes. Yeah.
Okay.
Okay. Thank you.